Hi, class. We are doing our section, 18.2. 18.2, Introduction to Trigonometry. The first question is, what is trigonometry? Well, trigonometry comes from a 16th century Latin derivative from the Greek word, I need a pen. That'd be right. Okay, so if you look at the word for triangle, trigonon in Greek is triangle, and metron is a Greek word for measure. All right, so what trigonometry really is, it's the branch of mathematics that studies relationships between the sides and angles of triangles. So let's see. Studies relationships between sides and angles of triangles. And that's all it is. So what we're going to be studying is the relationships that we know of that exist between the angles and sides of triangles. Now, if you look at this triangle over here, I'm going to try to move my face out of the way here. If you look at the triangle over here, you have trigonometric ratios, and you see a right triangle. So trigonometric ratios, sine, cosine, and tangent, they're called. I'm not sure that you ever even heard of those, but ratio, remember, is something different. A ratio is like A to B, or 1/2. That's what a ratio is. So a ratio is fractions, and we know fractions can be simplified. Fractions don't, they have a lot of different names for them. They're not just a singular number, like 1/2 is the same as 3/6, which is the same as 4/8. You can come up with an infinite amount of numbers that, as a ratio, really equal 1/2. And so that's the tricky part about these trigonometric ratios, is they are ratios, so they are fractions, and they can be simplified. And anytime you put a number over a number, then you're creating a few additional parameters that exist with that. So when we are dealing with right triangles and trigonometry, we are always dealing with these angles here. Okay, we don't deal with the 90-degree angle in a right triangle in trigonometry. We only deal with the two, what they call acute angles, and they're acute angles because they add to 90. Therefore, they each have to be less than 90. All right, so what we're looking at is those angles. Now, a ratio of sides and the angle measure have a relationship, and that's what we use a lot of times when we're outside in nature or outside and we want to measure something. We can use sines, cosines, and tangents, because we know for a specific angle, we know that, say, the opposite side divided by the hypotenuse of a right triangle has to be a specific number. It always is. So of those three items, we have an angle and two sides. With the angle and two sides known, if we know for sure that if we can come up with one of the measures of the sides and the measure of the angle, then we can come up with the third measure, which in this case would have been a side measure. And that's what's most important. And that's why we use right triangle trick. We use it when we're hiking. We use it when we're measuring things that you see, like the golden or the delicate arch. We want to know how tall it is. We want to know how much erosion is happening each year or each 10 years or whatnot. And we do that using right triangle trigonometry. If you have a house and there's a tree nearby and the tree is dying, and you think, oh man, if that tree falls on my house, is it going to hit my house and cause destruction or hurt somebody? You can use right triangle trigonometry to measure the height of the tree without actually climbing up to the top of the tree and measuring as you go, or dropping a tape measure from the top. You don't have to do that because you can use shadows or you can use right triangle trigonometry. You can just come up with a side, walk away from the tree a certain amount. Use a climometer, which they use in order to come up with angle measures looking at the top of the tree, and then you can come up with the other side, which would be the height of the tree. And it's useful, very, very useful in our world. And so you're going to just learn the basics of it. What we see here are sine, cosine, and tangent. Sine, cosine, and tangent are specific, let's talk about specific side ratios. So for instance, like the sine, cosine, and tangent relate two of the sides to a specific angle. Now, because all of these triangles are made differently throughout wherever we're at, we are relating two sides specific to an angle. All right, so always to an angle, and that's why you see sine A and sine B here. Oh, I hate it when it does that. You see cosine A and cosine B, and then you see tangent A and tangent B. Well, tangent of A is going to be different than tangent of B because A is an angle here and B is an angle here, and tangent relates two sides according to the angle. Now, what I'm going to go through first is what those ratios are, and then we might have to start with another video in order to come up with the remaining bits of information here. So for each acute angle, that means in this case A and B, because those are the only ones less than 90. The right angle we don't really deal with. You see the right angle over there. It's not something we look at. We only look at the A and B. So a sine, it relates the two sides that are the leg opposite the angle and hypotenuse. That's sine. So it's O over H, opposite over hypotenuse. So when we're looking at the sine over here, we're going to have to look at the angle specifically. So if you look at sine A, okay, sine A, then we come over and we find angle A, okay, angle A, and then it says opposite over hypotenuse. Now, when you find the hypotenuse, this is the hypotenuse right here. It's always across from the 90-degree angle is the hypotenuse. Okay? That always is the hypotenuse no matter what. The other two sides are legs. And the legs of this triangle are either running into A or adjacent to A, or if I go straight across from A, I have an opposite leg. Okay, so when sine says the ratio of the leg opposite the angle to the hypotenuse, then I go to A, I go to the opposite leg, and I see that's A, and then I go to the hypotenuse, and that's C. So A over C. I'm going to try to write that so I'm knowing it moves. Okay, that it gets in the right spot there. So A over C. So again, what we did is we named for A what those sides are. This is the hypotenuse, this is the opposite side from A, and this is the adjacent side from A. So the sine relates opposite over hypotenuse, opposite over hypotenuse. So opposite is A, hypotenuse is C, so it's A over C. Okay. Now, opposite over hypotenuse of sine B, hypotenuse is going to be C still. So if we're moving on to this next one, hypotenuse is still going to be C. So whatever it is, it's going to be over C. But B here, all of a sudden has a different opposite and adjacent, although hypotenuse is still there. When we're looking at B, opposite is now this leg, which is B. That's opposite, right? And then hypotenuse is still C. So sine B is B over C. It's opposite still, opposite over hypotenuse, always that, but opposite depends on which of the two angles we're looking at. If we're looking at angle B, then opposite is little b, and then hypotenuse is C. If we're looking at angle A, opposite is little a over C. All right, so that's what we're looking for. Cosine if you look at cosine, it's the adjacent over the hypotenuse. All right, adjacent over the hypotenuse. So remember that adjacent line was the one that ran right into it, right into the angle. So like for A, we're going to look at A here. Adjacent is the leg that runs right into the angle or is part of the angle. It creates the angle right there with the hypotenuse. Okay, so this is adjacent and this is hypotenuse, and the hypotenuse remains the same. So with the cosine of A, we find angle A, we find the adjacent side, which is B, and then the hypotenuse is C, so B over C. But when we're looking at B here, cosine of B, notice the angle is right there, cosine B, so the angle follows the ratio. If I'm looking at B, adjacent now is A. It runs right into the angle B right here. So it's A over C, the hypotenuse. Okay. Now, so remember that's A over H. Sine is O, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then the tangent is opposite over adjacent. Opposite over adjacent. And again, it depends on which angle you're looking at. All right. So I'm going to leave the hypotenuse alone, or try, because it's always the hypotenuse. I'm going to try to erase these. And we're going to look at, write in blue for A. So if we're looking at tangent A, A is right here again. So tangent is opposite, which is A, over this adjacent, which is B. A over B. Okay, for tangent A. Then, next we're looking at the blue B. So this all of a sudden is adjacent, and this is opposite. So the tangent of B is going to be opposite B over adjacent A. All right. So that is how we figure them out. Now, I only have one more minute here. So if you can remember, so, ka, toa, that's what people always think of. It's an acronym that helps you remember what trig ratios belong to each of the trig functions. So the sine theta, that's the S part, is O over H, opposite over hypotenuse. And the cosine theta is A over H, adjacent over hypotenuse. And the tangent is opposite over adjacent. Okay? So I'm going to stop the video for a second. And I'm going to have you go to part 2, and we'll relate all this information to our examples.